Hello, I'm Minyoung Park, a master student at the DTM Lab. Today I will be presenting a review of the paper Post-hoc versus ante-hoc explanations, xAI design guidelines for the data scientist. I chose this paper because as machine learning models are increasingly used in practice, I wanted to explore which explanation methods are most suitable for different scenarios and share these insights with lab members. This presentation follows the structures of the original paper. Here is the bibliographic background. The key objective of the study is to address the gap between the development of xAI methods and their actual use in the practice. To do this, the authors propose a decision support framework based on a literature review and interviews with data scientists. This framework is designed to help practitioners choose appropriate xAI methods for specific tasks. For the introduction and motivation, as AI models grow more complex, the black box issue, where decisions are hard to interpret, has become a major concern, especially in high stakes areas like healthcare. This reduces trust and hinders adoption. To address this, XAI gained attention. While many XAI methods now exist, there's a little guidance on how to choose the right models. This paper compares post-hoc and ante-hoc xAI techniques, evaluating their trade-offs and practical use. It proposes a decision tree to help data scientists and policymakers select the best method for their needs. For the background and related work, first one is explainability, interpretability, and trust. For XAI concepts and importance, explainability, which means why a decision was made, and interpretability, which means how the model works, are distinct but essential. Despite growing interest, practical guidance for choosing suitable XAI methods remains limited. And for human-centered design in xAI, xAI should answer user questions like why this results with interface that balance complexity for non-experts and depth for experts, especially critical in domains like healthcare. Lastly, for trust and responsible AI, explainability is vital for building trust and ensuring responsible AI alongside fairness, security, and transparency. Human in the loop design helps align AI with expert knowledge and user needs. So they explain that anti-hoc methods are interpretable by design, while post-hoc methods explain models after training. Sheffield fairly attributes feature importance using game theory, offering intuitive explanations. Anchors provide simple if-then rules that explain predictions with stable conditions. Post Post-hoc methods help make black box model more understandable. Anti-hoc XAI models are interpretable by design. Examples include decision trees, use simple if-then rules, easy to visualize. Generalized additive models show each feature's effect clearly, even non-linearly. Bayesian rule lists provide probabilistic if-then rules for both prediction and explanation. For explanation, quality can be assessed using criteria like accuracy, fidelity, and comprehensibility. Causability, how well users grasp cause effect from explanation, is also the key factors. The study organized these factors to guide XAI methods selection via a decision tree. For the methods, Chapter 3 covers the study's implementation of XAI methods. Post-hoc techniques were applied to a simple neural network using Shapley and Anker's tools. Ante-hoc methods included decision trees, GAM, and Bayesian rule lists, all implemented with standard libraries. The complexity was intentionally kept low to balance performance and interpretability. The four evaluation criteria for comparing XAI methods are completeness, how well explanations cover the model's output, correctness, fidelity, how accurately explanations reflect the model's behavior, including feasibility, compactness, simplicity of explanations excluded here due to varying standards, and user suitability, how well explanations suit different audience like data scientists, non-experts, and general users. The criteria for selecting xAI methods start with whether the model is inherently explainable, like ante-hoc, or needs explanations added after training, such as post-hoc model. And next, the target user type is important too, like data scientists or non-technical experts and general users influences the method choice based on the explanation's purpose. Runtime performance is also important, especially for real-time needs. And finally, for post-hoc methods, coverage is considered, distinguishing between explanations that cover the whole model or just specific instances. xAI techniques differ in supported data, explanation scope, accuracy, and coverage. Anti-hoc methods have high accuracy and coverage. Shapley is accurate with good coverage for low-dimensional data. Anchors and the dice offer accurate but local explanations with lower coverage. Performance varies by implementation. Structured interviews with five data scientists assessed six XAI methods using a within subject design. Participants, mostly with data science experience but unfamiliar with specific XAI tools, evaluated usability and understanding through case based explanations. Analysis used qualitative content analysis with predefined categories and questionnaire. Methods included Shapley, anchors, counterfactors, and anti-hoc models, each presented with interactive or example-based explanations. Participants explored explanations of six popular XAI methods, like three post-hoc model is Shapley, anchors, and dice, and three anti-hoc model is decision tree, BLL, and GAM. Using the IRIS dataset, they rated understanding, coverage, user suitability, and limitations on a 6-point Likert scale. Lime was excluded and replaced by Anchors for better coverage. All participants received the same data but could explore freely. For the results, expert interviews revealed that XAI explanations often require significant time and manual effort, especially counterfactors and scoped rules. High dimensional data makes explanations harder and deferred visualization like Shapley graphs are confusing. While useful for data scientists, most methods are unsuitable for general users who may prefer simpler explanations. Scalability is a major issue too, with many techniques losing interpretability as data complexity grows. While Shapley is useful but hard to visualize, anchors explain individual samples well. Counterfactors help identify differences but are complex too. Decision trees are intuitive but get complicated. BLL looks simple but is hard to interpret and can overfit. JAMs are clear and handle nonlinearity well. Customizable explanation, dips, and easy integration with tools like Jupyter are needed. The study offers a decision tree to select from six xAI methods, as I mentioned, based on user type, runtime, and coverage. Post-hoc methods suit complex models, while ante-hoc models fit simpler, interpretable needs. The guide applies mainly to tabular data, with other data types needing different approaches. Post-hoc method choice depends on user type, speed, and explanation scope. Scoped rules work well for non-experts. Data scientists can use most post-hoc methods. For fast research, counterfactors and scoped rules are quicker than Shapley, which can be slow with high-dimensional data. Shapley is best for overall model insights, while scoped rules suit clear case-by-case explanations. Counterfactors may cause misunderstandings. Anchors offer consistent, accurate explanations. Anti-hoc method choice depends on user type and needs. Experts prefer Bayesian rules list for complex interpretations, while decision trees and GAMs are more intuitive for general users. Decision trees offer fast training and inference. GAMs handle nonlinearity better. Intrinsically, interpretable models are preferred, and decision tree based models remain strong for tabular data. For the discussion, this study shows that most XAI methods mainly suit experts, with non experts finding them hard to use. It highlights the need for more user friendly tools. Scalability and visualizations issues also limit interpretability, even for experts. Data scientists struggle to fully understand models, emphasizing the need for scalable XAI approaches and further research with diverse users and data. And for the conclusion, this study identifies key usability, scalability, and accessibility challenges of XAI from a data scientist view through literature review and expert interviews. It offers practical guidance with a summary table of six major methods and a decision tree based on user type, runtime, and coverage. Limitations include a simple dataset, few experts mainly from data science, and basic visualizations tools that may struggle with complex models or large data. Thank you for listening.